that's okay.
So we'll start 2 minutes early. I'd like to introduce Alexander Krylovsky, a Russian researcher in IoT. And thank you very much for coming to FOSDEM.
Okay. I'm going to introduce you to Patchwork, our lightweight IoT toolkit. So as you all know, and looking from this program, everyone knows that the IoT is multidimensional. It has different stacks. It crosses different layers. So what I'm going to talk about is basically one layer above what the previous talk was about. So once you got your sensors connected to the platform like Raspberry Pi or the Galileo, and you want to actually make the Internet of Things or a network of things, you want to communicate over the network with them, you need to expose them on the network somehow. So the IoT starts with devices. There is a lot of them, and they are all different. Those are industrial devices. There are some DIY electronics. There are things like Sphero, for example. Wunderbar, interesting thing. Haven't got my hands on it yet. Then we connect them together. So one step is assemble those devices, then put them on the network. Can be wireless network, can be wired network. But the eventual goal is, of course, well, maybe not, but for the most stuff I encountered, the main goal is to build the applications from it. And the applications are different again. Those are web applications, mobile applications. But what I think about them is that, unfortunately, today, we cannot talk to the devices natively. We still need some sort of abstraction, some communication protocol that the applications can talk, which are HTTP, MQTT, co-op, perhaps will be one of them. Yeah, I won't go into details here. So IoT today is quite affordable. For like 100 euros, you can get a Raspberry Pi and a bunch of DIY electronics. You can assemble it together. It's quite easy. The problem is then you want to build your applications. So how you communicate with your devices once you have connected them. How you discover them. And how do you communicate with them? Which protocols do you use? So at this point, you can set up your MQTT broker, for example, use MQTT library to communicate with them. That's fairly easy. You would probably hard-code the endpoints, hard-code it in your application. So once you set it up, it works. Once you're done with it, and in 2 weeks, that will be harder. You can hack together your own WebSocket server, for example, and then connect to it from web application. That also works. Or you can take an existing framework, right? There is a lot of them, and the Patchwork obviously is not the only one. The problem is that all of this framework, including the Patchwork, they offer, they have their own way of doing things. They are providing their own APIs that you need to learn. So this is the first step, right? And then you need to accept the trade-offs. So if you don't mind running a GVM with a dozen of OSGI bundles on your Raspberry Pi, then it's probably fine. But you need to get to that point, and you need to accept this. So what we think in Patchwork, basically we tried to build a small toolkit. We don't call it a framework. We call it a toolkit. Not even IoT, but rather network of things. But with Patchwork, we want to provide a simple way to take the DIY electronics, for example, like a Raspberry Pi with a bunch of sensors here, and to write a simple device agents or simple command line executables that communicate with the Patchwork using a standard input and standard output, which is the API that any programming language has. And then through these executables, we allow you to integrate these devices and expose them on the network using some common protocols like HTTP, MQTT, and we provide some REST APIs so that your applications can actually discover those devices and can communicate with them. So the ideas behind Patchwork, we wanted to make it simple and lightweight. So we don't want to have virtual machines consuming RAM on your gateway. And we want to make the deployment really simple. So at the end of this Patchwork, you basically get a binary for your platform. And you don't have any external dependencies, no, a C library that you need to take with you, or something like that. It's platform and language agnostic. So we have native binaries for Linux, Windows, Mac, supporting x86 and ARM. And yes, as I mentioned, the device integration, so this step when you actually communicate with your device and then integrate with standard input and output with Patchwork, it's basically the programming language of your choice. And it's based on standards. Whenever we could use the standards, we try to do that. So at the moment, those are HTTP and MQTT. One is for request-response communication, the other one for pub/sub. And we provide some REST APIs for the applications, and I'll show that. So how can you build an application with Patchwork? Well, the first step, you need to assemble your devices. You need to communicate with them locally. Like, for example, what was shown in the previous talk. Then you put the Patchwork binary in there, do some basic configuration. And then you need to implement a simple device agent, which is a simple executable, which communicates with your device through GPIO or some other way. And then you configure these device agents, these executables with the Patchwork. And you basically start the gateway. And once you have started, you get the zero-conf network discoveries, DNSSD. So running on a local network, you can find that there is a device gateway that has this and this device connected to it. There is the REST API with the device catalog on every gateway, or you can run a global catalog in the network. And you get the HTTP or MQTT, depending on what you have configured for your devices. I didn't bring a Raspberry Pi with a bunch of electronics with me. So instead, I have a short video. I'll explain you things which are shown here. So this is a Raspberry Pi. It's a Model B+. There is a breadboard, and it's equipped with several sensors. So of those sensors, there is this thing, which is the PIR sensor. I think it's, as far as I remember, it talks with GPIO through the breadboard of Raspberry Pi. Then there is this barometric sensor. It has the altitude, the temperature, humidity, barometric pressure from it. And then in the front, there is the USB dongle. This is the air quality sensor, which is quite fun. It uses measures volatile organic compounds in the air and provides the measurement of it as equivalent to CO2. And then finally, the fanciest part probably is a magnetic sensor on the window. So this one basically reports when the window is open or it's closed. With the Patchwork in binary distribution, you get the dashboard. It's a free board, actually. It's open source dashboard. It's very nice. It's very simple to configure. So you basically provided the data sources in JSON. And then you configure what of them you want to show. And it has some widgets already set up for you. So you can select the widgets you like the temperature in this case, the altitude. I guess I will be opening the window right now. So there are different widgets. And you basically get this together with Patchwork. You just need to configure how you want to show the data from your devices. So I opened the window, and there is a light bulb indicating that. The device catalog API, I will show you that as well. So running on the device gateway, which runs in this case on Raspberry Pi, I have all the devices connected there. They are configured. And I have a simple REST API where I can access the information about those devices. I can get the configuration of the MQTT broker, where I found the broker, what is the topic where the data from this device is published to, or what is the HTTP endpoint when I can send a GET request and get the latest value from my temperature sensor, for example. Yeah, this was it. And you basically can plug it in your applications, something like dashboard or something more complex. So I'll go a bit into more details of some components, and then I have show you another demo, physical, this one live. So the vision of Patchwork as a network of things is basically that you have your network where you run several gateways connected to several devices. It can be your smart home, can be smart office, or something like that. There are several other components, the device catalog, which you can have one for your network, and then you information about all the devices in the network will be published there. And then there is also some mechanisms for discovery. The device gateway architecture looks sort of like this. So on the very left, you have your devices, which communicate their own native protocols. It's Bluetooth or Wi-Fi, well, or a USB. They're obviously not limited to that. So then the device agents, which are your pieces of software that you develop that communicate with the devices with the native APIs, and then communicate to the device gateway where standard input is standard output. Yeah, so then, and in the end, you basically expose these devices using some protocol like Rust and MQTT. At the moment, we plan to add co-op, but haven't managed to do yet. Well, interesting about it, probably the device gateway has all other components implemented in Go, which is why we get the natively statically compiled binaries. We don't have any external dependencies because it's statically compiled. So you just, as I mentioned, take the binary, drop it on your Raspberry Pi, and you're good to go. And device agents are platform technology independent because all the communication is done through the standard input and standard output. The device catalog API, probably the one that your application wants to talk to, because you configure the patchwork, then you start this, and then magically it creates all the endpoints for your devices and the topics for MQTT and so on. So it provides the CRUD interface for devices resources if you have one running on your network, but every device gateway runs its own, which is read-only. And it's a catalog with pagination. You can do some simple filtering and search. So if you search for device-specific capabilities, you can also do that. So this is how like a single device looks like in the catalog. You probably cannot see it, but here you have information about the endpoint for REST API of the device. And you can see that the supported methods are get, so you cannot put anything or post anything to this device. This is a simple sensor. You can just get the latest value, for example. And it provides information in which formats those messages are delivered. Discovery is another interesting part. So as I mentioned, when you hack your things together locally, you probably hardcode the endpoints, which is fine. But the problem is that if you go to another network, everything changes and nothing works anymore. There are some protocols for this, of course. There is DNSSD, which is basically a multicast DNS, which means if you run on the network that supports multicasts and you have a DNSSD client, you can discover that there is a patchwork gateway running on this network. You can take it and you can get to the device catalog basically absolutely automatically. And from that point, you have the device catalog and you can start discovering devices and can communicate with them. Yeah, this is just the output of the device catalog. Yeah, so another demo. This is the Sphero. I don't know if you don't know about the device. Well, it's a toy, okay, but it's also a robot. It has two motors. It can stabilize itself, as you can see. It also has accelerometer gyroscope. So this is a device which is good for light traveling for demo because it's basically a sensor. It's also an actuator. So I'll go just to put it here and show you some. I won't probably go into code, but so the Sphero communicates with Bluetooth. In this case, it's my laptop. And I have a simple tool, which what it does is, how do I do that? OK, so if I run Sphero, this is the tool. It basically just connects to the Sphero, and it starts reading data from it, which will be the sensor data, is accelerometer, gyroscope, and so on. Somehow it doesn't work yet. Yeah, so there you go. Here comes the JSON, like a bunch of data. You can get a lot of data from this thing. Really, quite overwhelming. So once I have this binary, it's also so basically it just provides me it writes stuff to std out JSON, but it also accepts the std in. So if I basically I can send commands to Sphero. So once you do it locally, everything is fine. But now imagine you want to do it over the network. Yeah, so this is the configuration for the device gateway. It looks a bit complex, but it's actually not. So here it just I provide a name description, some metadata if I want to search later. For example, if I have 100 of zeros running my network, I can identify them through some meta key. What's important here is this configuration of the device agent. So I say that this is agent of type service. Type service means that this is the agent which constantly running. It writes stuff to std out, which is the output from the device, and it accepts stuff to std in, which means that's communication in another direction. And I just provide the path to executable. I say, OK, I want to enable the communication over HTTP with Sphero. So this will be a protocol of type REST. It supports two methods, get and put. So I can get data from it and actually put something there, which means running it some command on Sphero. Well, this is actually not correct because it's not SendML, but a JSON. And I also enable MQTT with the only methods publishing, which means that the sensor data from the Sphero will be published to MQTT broker. I'll probably show you the configuration of the device gateway as well. So the configuration device gateway is much simpler than that. You basically say here what is your HTTP configuration, the bin address, bin port, and you say what is the MQTT broker and which prefix to use for the topic. So let me just do that. I start the Mosquito MQTT broker. I start my device gateway configured with the configuration I just showed you. So you basically see that the device gateway connected to it and started publishing data. So how can we see that? We can use Mosquito clients. So what I say is connect to, you probably cannot see it. Just a sec. So what I say is I connect to my local broker. This is the topic. I should probably show you how I get to the topic. This is the device catalog API, which I mentioned previously. Here I see that there is a device, which is the Sphero. There is Sphero API. And it uses MQTT protocol. This is the URL to the broker, and this is the topic. So the topic has been just generated from the configuration of it. So if I connect, I get my data. You can also see here that the Sphero supports the HTTP REST communication with the get and put methods, right? So if I use HTTP request here, I get the latest value from Sphero, right? Yeah, what's more interesting about it, of course, is I can do some things. I can change the color to blue. So this is obviously just a simple JSON which sends the command color blue. There is also the dashboard. So this is the freeboard. Oh, doesn't feel well scaled. So for freeboard, for example, let's take this is the Sphero device. In the configuration, I provided a URL. I say send a GET request every 1 second. The content type is application JSON. And then I configure, for example, accelerometer here. No, I don't want to do that. That'll be the one. So this is how you configure the dashboard. It just parses the JSON, takes the single value from it. So if I do stuff like that, you can see changes. Yeah, so the last and the most dangerous thing, I can ask Sphero to roll. I don't know any direction, but let's try to do that. It rolls, yeah. Yeah, that was it. If you want to find out more, Patchwork is open source, obviously. It's on MIT license. You can go to GitHub and find it. We have the agent examples repository where you can find stuff, for example, like how you can connect to a sensor connected to GPIO and Raspberry Pi. I don't know, we have like a dozen of agents right now. So if you develop one, of course, pull requests are welcome. We have a wiki. We're trying to actually document things properly and make it easy for people to start and understand what's there. And we recently published an article on the Gopher Academy blog. So the Gopher Academy blog is just popularized Go, and they had like a program for the Advent 2014. And there you can find a lot of interesting, maybe interesting for you, implementation details of PyTorch, where you find Go really interesting and productive. And using it for IoT, yeah, it has been a good experience. So any questions?
Alexander,
Was it so
how
good?
much does that cost and where can we find those?
Expensive. It was €100, I think. I don't know. It was a present, so you can ask my girlfriend. She's there.
And what's the connectivity on the Go?
It's Bluetooth. I think it's the 4.0 low energy.
I have a question.
Yes.
The protocols and all that stuff, did you have to write that beforehand, or does it detect it itself, your framework?
Which protocols?
For example, for the SpheroBall, there were already protocols, which ones to use, which ones are allowed. Did you put that in some configuration file before?
Okay, so the question was whether the configuration of the protocols is detected automatically.
Yes.
Okay,
Exactly.
the answer to this is the configurations are generated from, well, the configuration of the protocols for devices is generated from two configuration files. So one of them is the configuration of the device gateway. So here we provide what is the TCP port we use for HTTP server, right? What is the bin address of the HTTP server? What is the MQTT broker that you use? And what is the prefix for this specific device gateway on that broker? So this is one part of information which is shared among all devices connected to the gateway. And the other part is what is actually the information which is provided in the configuration of a specific device. So here, the device has name Sphero, and it has a resource of name Sphero API. And this is the configuration of the agent, right? And then I say that for this device, I want to have REST communication. I want to have HTTP communication with it. And here I don't provide the specific URL, for example, right? I just say that I want to have HTTP communication, and I say that I want to have MQTT communication. I don't configure the broker here. I don't configure the topic here. So then information from both configuration files merge together, and we get this URL, and we get this topic. So it's convention over configuration, probably. I guess you can say that. There was another question? No. Oh, maybe I forgot it.
Okay. Alexander, thank you very much for that.
Yeah. Thank you.